Thanks, Mel. So I'm fortunate enough to be a partner solution architect here at HashiCorp. That means that I get to work with the likes of the wonderful Simone. So if you'd just like to introduce yourself.
Hi there, I'm Simone from Microsoft. I'm a cloud solution architect in the partner team.
And what that means is today we get to work together and talk to you about some of the problems that we've seen, some of the things that we've seen to be able to fix those problems, and some of the commercial elements that align to what these problems are actually driving. So what I've tried to do is tie this together so that in this presentation, not only will we have an understanding of some of the technical elements, and Simone's going to actually drive some of those to show you the close alignment between delivery from a partner's perspective, so from Microsoft's perspective, and also from the ability to drive and run this within your Azure infrastructure. Well, what I wanted to do was just take a quick step back and kind of sum up why and what some of these elements are and some of the mechanisms are driving these and why it's really important and where we see the opportunity as customers and partners to take advantage of how Terraform can be used to solve these challenges. And so HashiCorp has been around now since 2012. We obviously went public recently. And in that time, we've been really fortunate to be punch well above our weight. We have a lot of G2000 customers. We are on strategic partner lists of many large organizations that startups of our age would only dream of trying to get access to. But what that means is that we have this broad range of access to information and customers as they try to solve or meet the challenges of cloud or multi-platform. And last year, we undertook a survey, a cloud survey, to see what customers were thinking about, to see what they were trying to solve, and see what challenges they were coming up against as they tried to migrate and move workloads into the cloud and adopt a more cloud or multi-platform approach. And so the results came back from that were interesting in that there were kind of these three main categories that we tied things into. The first of them being around time to market. So this is around how can I get in front of my customer? How can I get things to my customer faster? How can I make changes to that customer experience faster? Now, obviously in the last couple of years, as we've moved into a world of chaos and global pandemics, this has become more and more prevalent. We've seen obviously a pivot to a digital first presence. We've seen customers moving away from wanting to actually engage in a traditional way and having to build a digital presence. And that digital presence also having to change quickly. Good examples of this is when we had our COVID tracking app, when we first started using it here in Australia, you couldn't add in anyone else. So if you was taking the kids into a shop, you had to do them, and then you had to go log out, and then it's just that obviously was a really poor user experience, and no one wanted to use it. And they pushed that change out within a few weeks of getting, well, I think a few weeks of getting the feedback and everyone complaining about it to actually turning it around. My local coffee shop, who were very adamant they would never do anything other than takeaway and dine in, suddenly pivoted to having the ability to actually have online orders, random delivery, pickup, just because they needed to do that and pivot their business. And so that flexibility and that time to market, whether you're a government, whether you're a small kind of business, is starting to become key in terms of being able to have a digital experience for your customers. On the flip side of that, as that speed and momentum and flexibility comes into play, so the ability to have ingrained security, ingrained control, and also control of the overall spend. How am I going to control what is deployed? How do I make sure it's deployed at best practices? Again, kind of coming into what we're talking about later. How do I make sure that I can do things in a secure way right from the start? How do I build that into my delivery? And so we cover off and talk about some of these things. And the last one, which was I thought was the most interesting, in terms of the surprise pick of the bunch is that operational efficiency. And so what that means is as we get or push to have more speed to market, make more changes, be more flexible, as we are pushing, how do we make sure that these changes are really secure? How do we make sure that they meet all of the controls that we need within the business and regulatory and compliance elements that we have to do? How do I make sure I track it so I can associate costs? All of these mean that there is a more operational burden. However, those operational teams are getting smaller. They need to make more changes. They need to scale across globally. Some deployments. I know internally, within our own business, as we start to roll out Terraform Cloud and Terraform HashiCorp Control cloud platform across the region. How do we deal with those operational changes? How do you make sure that they can all be pushed out into the same region? How can you do all of those things? And so controlling those and having those day-to operational controls means that you need to be able to make consistent and repeatable changes. And so as part of the thinking around how do we do this, obviously we have long had our cloud operating model, but the cloud operating model now really starts to resonate as it falls into those or solving those challenges. So for those that aren't aware, the cloud operating model is how we see customer maturity as they go through that life cycle. And so as they move through that life cycle to trying to achieve one of those, either faster time to market, security, or operational efficiency, and start to move across a multi-platform delivery, so they're going to hit these challenges. And we know they do. We've seen that all of our customers come up with these challenges. And it's driving a lot more of this Hashi stack kind of thinking where all of the products are integrated together, work very closely together to solve these overall challenges. And those challenges also depend on that maturity curve of the customer, depending on where they are in their life cycle. So, if you see someone who is doing early cloud adoption, then for them, they're probably going to hit, how do I build? How do I hit infrastructure? How do I make the infrastructure changes as easily as possible? If you have a financial organization, for example, then they're going to be coming at the problem of how do I make sure security is front and center of everything I do. If you are running from a networking or it's coming from a dev, then applications and networking infrastructure or connectivity are going to be key drivers around that. And this is when we see that this touch points at those individual products. But as that starts to move to a platform delivery, so all of the Hashi stack, so to speak, comes into play around how do we solve that challenge. And so I think what is also key is understanding that HashiCorp has a lot more products other than those 4 key Hashi stack problems. So those 4 key ones will build your enterprise strategy. You can tie your enterprise strategy in. You can deliver them. They are built to be, or they're made to be delivered at enterprise quality with enterprise level support and enterprise and collaboration and controls across a large scale enterprise. But some of these open source projects that we also own and build help you drive that thinking around how do you then start to build that infrastructure and automation into the process. And so as we go through and talk about some of those other more maturity elements around how to build that workflow, how do you bring those in, we'll talk about things like Packer, which builds AMIs. I know within that environment, you can use it to build an Azure AMI, for example, and then you have a golden image that can be used to deploy sets of infrastructure or server elements that you want to draw into your overall environment. And you can create those uniquely. That also then helps to get that security and governance, compliance, regulatory control into that build process. Another thing that we also seen is obviously digital transformation. There's a lot of customers talking about this. There's a lot of customers that either have or are thinking about or are talking about having a digital transformation journey. And what this really is seeing how they can take advantage of the cloud and actually pivot their journey to deliver to that we need to be time efficient. We've seen examples of this where organizations need to actually or have worked like with Shell and Microsoft, have come together to actually come up with a full digital transformation that then actually moves them out of a particular data center or around the timeline, sets up their migration journey, and actually ties in real business values around whether that's insights from business analytics or leveraging either the data now that it's in the cloud to actually get better analytics and insight into their business. But digital transformation is basically the driver that we see pushing all of these changes, including those initial problem areas that we talked about at the start. And so now we've kind of talked about what the business problems are, we can talk about some of the people problems. One of the biggest people problems is obviously a lot of the fundamental way that we are driving change within organizations, or particularly traditional enterprises, is has been built and is established around a standard ITIL process. And so what that means is that you have a developer who needs to deploy or build some infrastructure element. They raise a ticket. That ticket is then assigned to a traditional infrastructure owner. So that was my role in the past, for example. And I know, we would pick that ticket up, and then that kicks off a whole process. Do they have, is this a custom project? Do they have funding for that project? Where does the budget come out of? Do we have ability to actually put this under our standard capacity plan? Does it fit under, do we need to buy specific hardware? Do we need to actually tie it, how are we going to back this up? How do we make sure that it's included in the maintenance cycle? Do we need to have a new switch? Do we need to physically wire any of this in? And so all of those things took a massive amount of time and led to infrastructure being mutable, being loved and not cherished. I used to know the IP addresses of all of our key switches, and the reason behind that being is they were there for a long time. We know that they used to live for 3 to 5 years, depending on the write-off, and that infrastructure time, or that infrastructure was there and known and well controlled. Now, whilst that has advantages, particularly in terms of either security or controlling costs, it doesn't help solve that challenge that we talked about in time to market or operational efficiency. When I think about how we used to try and do this, we had a massive team that to make some very simple changes and was very people process criteria. With the advantage of leveraging something like Terraform, we obviously introduced this idea of infrastructure as code. And what infrastructure as code is doing is taking those best practices that the developers have been doing for years, leveraging that with a version control process and coming up with this API first thinking. So how do we start to leverage APIs that are available out of the box across the platform, make changes against them, be flexible with those changes. So now instead of the process taking days, months, hours, weeks, or half a year in a case that I know of, when I was working where we had to wait for hardware, this is now being done into minutes and even shorter time spans, where because this is now using code, you start to get into that element around the thinking around how to actually approach that into a repeatable and deliverable component that can be reused, stored in an easy way, and referenced by others. And this is starting to pivot to where we're thinking around the integration of that delivery. And this is where the whole thing starts, the basis of the thinking around using patterns and repeatability starts to come into play. So now we've joined the traditional software developer and the automation engineer or the infrastructure engineer into the same space. They're writing code together. They're writing as subject matter experts within that same pod. They're working together to develop across that same time frame, which is then helping to deliver that time to market. They're storing in a central or a single source of truth that adds into the control, starts to add in the ability to understand what changes are going to be made, understanding how you can trust those changes and test them. That's the other important part, is being able to make sure that you can test as part of that workflow, so that as you start to make changes, they are passing the tests, meeting standards, you have trust in what is going to be deployed. And so now you can truly rely on the automation so that when you make a change, you know that what you get out of the end is actually valid and reasonable. Integrating this in then with a a DevOps workflow tool where Terraform builds the underlying infrastructure elements, and then as those elements are provisioned and stood up, you can now then push customized components into that environment. Now, whether that's using something like Packer and pulling in a golden AMI, where you know you have a set defined criteria of packages or work or defined directory structure that you can then actually push specific or customized content into that. Then we start to tie together that ability to deliver a known quantity that's passed a set of tests and is completely customizable around the actual delivery outcome that the business needs. Now, whether that's a web server or a shared directory or some application that is being used for a particular project. So we've gone through how do we change people and process. We're getting into now how do we actually integrate this into what we're doing, and how do I get infrastructure as code into my delivery process. And so the key part around this is obviously at scale, and I think Simone and I had a interesting conversation when we was building this around how we approach it, what the workflows are. I think automation is obviously going to be key to anything that you do at scale, and being able to automate so that that does all of the heavy lifting for you is really important. So this concept of thinking around what dry is, and we talk about that a little bit, and then thinking around how to leverage all of the information that is out there is key to being able to build quickly, experiment as an individual, and then expand into actually making that an enterprise grade delivery that can be used across the business. And this is where the journey from experimenting and using with open source and then transitioning this into delivery at an enterprise level, leveraging something like Terraform Cloud or Terraform Enterprise, really has this very kind of clear lineation as you move through that automation. So to start with, you would probably be experimenting as an individual and working with Terraform open source as an individual. And then as you start to move this into how do I build this module and this repeatable element and start to get other people to use that in an easily and probably maybe even a non-technical element, then so you can actually push that out and leverage the enterprise grade delivery mechanisms like Terraform Cloud. And so, I mentioned this concept of dry, and fundamentally what it hooks around is the blueprint kind of principle. And so John Herschel in 1800 and something came up with this idea of taking blue paper and repositioning or reproducing engineering documents accurately and as a true likeness. And so this gave the ability so that they could do something once correctly and stamp out then subsequent replicas of that in an identical way so that everybody else knew exactly what was happening and everybody had the same information. And so that concept of don't repeat yourself is fundamental to tying into being able to automate and drive at scale. If you need to do something more than once, then obviously you need to think about how you can take that code set, pull it apart, take the variables and the deliverable components, define them in a way that you can then put dynamic elements into those or check against resources that are already known. So instead of defining a new uh, network or even AMI, can you use a data source to pull what existing AMI is already in there and pull that into your code? Think about how you can write the code in a way so that it is reusable within any construct, and then actually reference or create variables uniquely in that workflow component. And so, uh, that workflow concept then fits into an interesting kind of philosophy in that a workflow, and this was something that when I first came to HashiCorp, I kind of really had to get my head around. What we've been talking about is obviously a lot of the deployment, building code, writing, and delivering outcomes, which is what the business wants. But they're very workload specific. And so what we're talking about here is just taking a step back and integrating into a workflow, and that workflow then needs different touch points. So the workflow would sit taking your version control, being able to integrate that with a delivery mechanism. So say something like Terraform Cloud, use that repeatable module that you can use within Terraform Cloud. So Terraform Cloud for Business has the ability to have golden image modules. So you can take a best practice element, customize that into your own way, and then deploy that within within the module registry to use as a best practice. And then with that, you can also then apply Sentinel or our policy as code to that, so that as things then get deployed into your environment, so they have to meet set standards. So that could be tagging, that could be known IP addresses, it could be not allowing anything to go out that has an any policy on an instance connection. But that workflow is then delivering that outcome. The module and mechanisms it uses underneath are workload specific and always will be, because as you try to deploy across multiple platforms or multiple applications, so those things are unique. But the workflow that you build can be repeatable and flexible in being able to actually deliver that. And then you only have to build or use that don't repeat yourself thinking in creating those modules which become workload specific. And so in this example, what we're doing is just showing you how an engineer takes some code. So we're writing in Visual Studio here. So, we're leveraging a Visual Studio. I use it too. We have an integrated language support. So highlighting, auto correction, variable highlighting, all of those things are built into Visual Code. So that makes it, a great editor to use. We push that code into our repository. So we're going to push it into GitHub. That falls into our pipeline and triggers off that build process. And then, as I was talking about earlier, so this splits, it kicks off a Packer build. That Packer build now builds a custom Azure disk that has the right necessary images. Terraform builds the environment, stands up the machine. That machine gets put into a scalable set. So now we have an on-demand deliverable components of capacity. And we tie those into all the necessary business and analytic logging that we need to actually deliver that application. And so this workflow and this thinking ties what we've been talking about. So now we've had the change in kind of process. We've had the change in how people work, and we're delivering that around and tying it to a business outcome. So now all of these things tie together, back leveraging the cloud operating model and addressing those challenges around. You have a single team or a single member being able to meet that operational efficiency. You can build security, governance, and best practice into the delivery mechanism. And you can make loads of changes doing it this way. So you can make small or large changes fast to actually get to that better time or faster time to market. And so I hear this sounds great, but where are we doing this? Where's this in reality? Well, I think the concept of the landing zones is starting now to become somewhat of an industry name term that all of the cloud platforms are looking to or leveraging. And what that is the correlation of these kind of concepts around best practice in delivery. And so when I was working for a cloud, and I know as I've been working with partners and customers here, there's lots of questions to me. Well, what does this look like? How should we do it? You know this better than we do. How do you get that? How should we do this? And of course, then it turns into somewhat of a religious or political debate around, well, this is better than that, and this does. But what we try to do is look at a way to create a standard baseline that is flexible. Now, what this is doing is looking at how we can take that thinking around not repeating ourselves, building in a methodology where we're using smaller modules to create standard repeatable outcomes. So that could be a networking element, a an AMI image. It could be storage. It could be policies and governance and control. So how do you set up best practices around people management, which a lot of the particularly early adopters of cloud, I have seen really struggle with the way that they implemented those governance and access for people because it wasn't really tightly controlled. It wasn't thought about how do they do that at scale, and now they have all these processes and accounts all over the place. Putting in all of these things into a repeatable pattern that you can call, you know exactly how it's created, you know exactly what is done, and you know exactly what can be deleted as well, which is another important factor in that repeatability. Where I think a great collaboration is we have worked with Microsoft, and this is I'll be passing over to Simone to go into more details around where this came from. But basically, they took their best practices and started to look at how they could build out exactly that principle of landing zones. How can they take individual components, create a a standard and a best practice around that, be able to tie this into an easy format for customers to consume. So they leverage Terraform to doing that. So it makes it flexible. You can use Terraform straight out of the Cloud Console, for example, without even having to install it. Or you can leverage, and I've worked with the team where we can drive this from Terraform Cloud. So you have operational efficiency and scalability around multiple teams right from the word go built into that delivery. And this is focusing around those individual elements and giving you the flexibility to really kind of build and deliver what you need from the Azure platform. If you want to take a kind of broader approach, one of the things that we also do is there is enterprise scale. And this is kind of going that next level to kind of figure out all of the different moving parts. So how do I do policy? How do I set up best practices around identity management and IAM? How do I give control to different groups? What's needed to actually build individual security concerns? How do I tie that in and manage security components, for example? All of these things are, you know, a lot bigger look at solving that cloud challenge. What is really great is both of these solutions are in our module registry. So when I spoke about that private module registry earlier in Terraform Cloud, we have a public registry. That public registry has a whole bunch of best practice like this code that is easily consumable and downloadable into for you to use and to deploy and make your own. So you can then take this, stitch them together, customize them, make them into your own modules or your own private modules within that Terraform Cloud environment that delivers something specifically that you want to do. So this is a great way to then kickstart in that golden standard. So you start building and leveraging the right processes and the right way of approaching it with the right controls right from the start. And then you can start to stamp it out. The other advantage of this is obviously because this is now known and quantifiable, you can start to delete things. So now you start to get the real advantage of being able to actually on-demand usage. How do I take an environment down? How do I know what has been deployed? How do I know what I can delete? Which, you know, I know in some environments that I've worked with, particularly where people have changed or you know, the team has progressed and that they've had different COEs trying to drive different objectives. They have accounts where there are parts that they don't know what it is they're doing. And this is, you know, fundamentally when we, you know, the whole advantage of cloud when we first started talking about it was this whole you know, ability to know, you know, you're starting from scratch, there's no technical debt, we know exactly what's going to happen. But obviously that hasn't happened, and that's, you know, in some environments that's got away from people. So being able to have uh, elements like this, like enterprise scale or leverage the Azure landing zones to be able to really deploy best practices from the start I know in that registry in the Azure CAF example, uh, there's minimum best practice, minimal viable best practice to deploy as well. So you can really experiment and get going very quickly to give you that jump start. You can then take that and those learnings and really kind of kickstart your journey and migration through your cloud. With that, I'm going to pass it over to Simone to kind of talk about where those best practices came from and how that tied into or deploying them and leveraging Terraform to do that. Over to you.
Thank you. Thanks for having me along. So I'll start talking about the Microsoft Cloud Adoption Framework, as Dave was saying, at a higher level. So it's not just about the technology. The Cloud Adoption Framework encompasses everything, right from defining your strategy as an organization, defining where your customer or your organization are at in their cloud adoption journey, right through to planning it, deploying it, migrating things or building things on it. And then I think one of the most important things that a lot of people, in my experience, don't consider at the start is how to govern it and manage it long term. So how do you keep it secure and cost optimized and all that kind of stuff longer term? As Dave was saying, even backed up. A lot of the people I work with, they don't consider that because they just want to get it deployed and working. So the Cloud Adoption Framework has iterative phases that advance your business through the complete life cycle of cloud adoption. And the framework is very big and detailed, and it addresses common blockers and documents best practices for everything through migration to deployment. So it even has all the different subcategories like data and virtual desktop, all that kind of stuff is addressed. So if you're trying to consider how you might build a landing zone or you might migrate your company or customers in a better way, then the Cloud Adoption Framework would be really helpful for that. And I was joking with David earlier, and I don't know if you'll find this joke funny, but I would classify it as being quite dry. Anyway, so today I think we have a more technical audience. So I just want to skip down to the next slide, which is the ready phase. You can please, he's just being nice and laughing at my joke. So within the Cloud Adoption Framework, right in the middle, there's the ready phase. And that's the one that most tech people care about the most. It's the one I find the most interesting because it's where you're actually writing the code and deploying the landing zone and having those debates around best practice. And I guess some of the feedback Microsoft got over the years was that people wanted a authoritative, proven and prescriptive guidance framework they could use and they could be confident using as their base for deployments. And so this framework helps eliminate all those long debates you have where you're looking at best practice. It just says this is how you should do it if you want to be best practice. And basing your landing zones and cloud adoption off the Cloud Adoption Framework is great because it's also updated as new things arise. So we all know one of the biggest challenges in cloud is that it changes so quickly. So one thing might be the best practice today, and then in 6 months, you need to revalidate that. So the Cloud Adoption Framework stays up to date by all the different product teams. I know I've worked in lots of organizations and I've worked with customers who are creating their own Cloud Adoption Framework and landing zones from scratch, and that's fine, but I would encourage you to have a look at this and not do that work yourself if you can just take this base and then build on it and customize it to suit your needs. Next slide, please. So as Dave was saying, when you go down from the Cloud Adoption Framework as a whole methodology, you have the landing zones, which is how do I build that basic infrastructure? How do I put those guardrails in place? How do I put the plumbing in place for my cloud migration or building my environment or deploying my applications? And so with the Cloud Adoption Framework and the landing zones from Microsoft, you can start small and refactor, or you can deploy the entire enterprise scale landing zone for, say, greenfield environments. The plus side to doing the enterprise scale landing zone and thinking about that stuff now is that you won't have to go back and refactor it once your company grows. Lots of people I've worked with started small, either for proof of concepts in cloud or as a startup. And then as the organization or their footprint grew, they had to go back, reconsider all the stuff that they had deployed, put stuff in place, try to retrofit it, sometimes even build new and migrate, which I'd be surprised if no one here has experienced that, but it takes a lot of extra work that you kind of wish that you had thought about it early. So using the landing zones and the Cloud Adoption Framework, you can avoid doing that rework later. It doesn't deploy any workloads it just deploys the plumbing and the infrastructure. So if you consider your networking, your subnets, VNets, Azure policy, so that you have guardrails in place, and future proofs the design. So you would build this, deploy it to your environments, and then put your workloads inside of it. Probably for me, the best thing about the Cloud Adoption Framework and the landing zone frameworks is that you can give people the freedoms they need to innovate and develop, but without having to manually implement all the management that you would have had to do in the older days. So as Dave was saying, you used to have to ask the infrastructure team to build your service for you because they wanted to make sure, they're backed up, they're resilient, they wanted to check off their list. Now you can put those guardrails in place and automate that. So if I try to deploy storage that's publicly available, it just doesn't let you. And if I try to deploy a server that's not secure or not within my budget, it just wouldn't let me. So no person has to manually check those things and come back to me. I can just deploy, innovate, develop without being hindered. Next slide, please. I'm going to jump around a little bit for the next few slides, so please excuse me. But one of the things when I was looking at the Cloud Adoption Framework that I was a little confused about initially was how the Cloud Adoption Framework and the well-architected framework fit together, because they seem like they were similar. And I just wanted to go through and explain that cloud adoption is that whole platform. So from the ground up, how do you plan it? How do you train people? How do you build a cloud center of excellence? How do you monitor and govern it long term? Well, as the well-architected framework, I guess, sits inside of that, and it focuses on individual workloads. So if I build my landing zone and I deploy my payroll application into it with all of the parts, then I would use the well-architected framework to make sure that that is reliable, it's secure, it's cost optimized, it's operationally excellent, and it performs well. And you can use something like Azure Advisor to do that on an ongoing basis, or you can just refer to the well-architected framework and follow the best practices. I would suggest using Azure Advisor because it constantly checks for you and alerts you. Next slide, please. I'm trying to make sure I don't go over my time. Okay, so jumping slightly to the side again is converting your deployed resources to code. When I've been doing deployments of landing zones and big migration projects, something that always was slightly painful for us is when you have brownfield. So the organization already has some resources in the cloud and you're trying to manage that environment using code so you can make it repeatable and you can use the code as your documentation. But then there's this small subset of resources that aren't in code and were deployed some other way. If you're using ARM templates, you can use AZOps to write that back to your repo in ARM templates. If you're using Terraform, which everybody here would be, I would assume. I was part of a hackathon recently for a project that's been stood up by one of the guys in our team, and it's called AZ Terrify, and you can point it to your resource groups and it will document the resources in that resource group back into Terraform code. So instead of having to go and look at everything and manually write the code so you can have a fully infrastructure as code environment, that can shortcut it a bit for you. It's still in progress, so if you're into working on open source projects, please get involved, or even if you're not into coding, you could give it a try and give some feedback. Next slide, please. Okay, so there are a few options for the Cloud Adoption Framework out there. There's buttons that just let you deploy it straight to your environment. There's a couple of repos. But this is the one that I use. Coming from an infrastructure background, I found it the easiest to understand and adopt. It refers to the registry that David was talking about earlier. And essentially it uses the Terraform CAF modules and steps you through. So starting off with one single file with your variables and main.tf and everything just in one file, and deploying some very basic stuff, to customizing it and growing it right out to enterprise scale landing zone, which is ultimately where you want to end up. And I think I still have a quick minute to show you that. Do I?
You'll do.
Try to go as fast as I could. Hopefully you can understand. I just need to request control, I think. So just 2 seconds. And I'll share my screen. I don't have a super exciting demo, but I'll quickly show you how it looks for me. Oh, I just need David to stop sharing.
There you go.
go. Thank you. Okay, great. So this is the Terraform module registry that I was talking about earlier. So you can find that by just Googling this, I suppose. But I use this repo, which refers to that registry. So there's a link in that slide I was just on. I'm sure it will be sent out after this talk. But the Terraform Azure RM CAF Enterprise Scale. And if you scroll down, there's like a how to get started. And that's what I followed to just build it from scratch. So you definitely can just grab a full cloud adoption framework, even enterprise scale, and deploy it without having to do anything except change the name. But I wanted to know, how do I customize it? How do I know what's in there? How do I explain to my customer what I'm going to deploy and make sure everything I want fits into it? So for me, that's why I went down this route. And the repo is really good. It's got a lot of how to customize things, what can you customize, what you can't change names of, all that kind of stuff. And this is essentially what you'll get. It's quite large, it's multi-subscription, it's authoritative and best practice, and you can take the parts of that you want, or you can use the entire landing zone. And then when I was saying there's options, these are the options. So you can see there's quite a few. You can start low, you can just do the foundation, you can do full hybrid with the full enterprise. There's a bunch of options there, and there's one down here for the Terraform, which are the ones that we are caring about today. So what I did was follow the repo, which is here, and I followed the how-to, and I just created a single main.tf that's quite small. So hopefully you can see that okay, but it's not very long at all. And then I just created a Terraform TF for the version and the variables with just the organization name, and I'll show you that in the portal in a second. I ran the plan while David was talking just because it takes a little while, but you can see that in the TF plan, it's going to create a bunch of policies and management groups and networks for me. So if I go over to the portal, you can see that I have no management groups here, it's just the root. And I don't know, I come from infrastructure, so I always think of management groups like group policy, where you have the OU and then you apply the policies to it. In my mind, this is quite similar. And that's how you apply that governance. So I'll let this run really quickly, and we'll take some questions, and then I'll show you that it worked.
So I can see there's a question in there around how do you manage config drift at scale, either using an open source or HashiCorp cloud products. I think there's so I don't want to speak for you, but I will start from a HashiCorp perspective, and maybe you can talk from your perspective afterwards. What we see is, I think, control and automation is the key element. So having control and making sure it's being driven from automation. So stopping people who shouldn't have fingers or access to the GUI fundamentally having access to the GUI and creating things. Once you have that workflow, then you can use something, and Terraform Cloud is a great way of doing this, to be able to drive and control change, because you know exactly what is there, and it will have a known baseline. The other way that I've seen it done is that's kind of the nice way. The other way that I've seen is the big stick, and that's where anything that is deployed has some form of secret squirrel tag or identifier into it, and then you run basically a workload killer that goes around and bashes anything that isn't actually tagged properly. And so depending on your approach and your relationship with your fellow developers, you can take kind of a friendly approach where it's kind of collaborative, or you can take the big stick approach and just whack their knuckles until they learn. I know internally we take the big stick approach, and it didn't take very long for everyone to realize that you have to do it, and you have to tag it, and you have to drive it a certain way. Otherwise, all the hard work you put in gets blasted, and there's nothing more frustrating for that. I don't know if Simone, if you wanted to.
Yeah, I would agree. So having policy, so the Azure policy would enforce that, and you can set it to be just warned. So some places I've been, if you create something that violates the policy, it alerts you and alerts the team who owns it, and they're on your case straight away. Or you can enforce it, like David's saying. So you just say you can't deploy these things in the console, or you can't create something with these settings and it just doesn't allow you, or as soon as you create it, it deletes it. So that definitely works. Policy prevents you usually creating it to start with. When it comes to configuration drift, I guess if you have other tools, the only other thing I've seen work well is those tools that go and grab the infrastructure, check it, and then write it back to code. And I think the options there are a bit more limited. So for me, I would agree with David and try and prevent people from doing that by using the governance measures that are in place. Policy is super powerful, so you can get right down to the nth degree with it.
So there is another couple of questions. One I might pass over to you. So how have you managed, or have you managed Azure DevOps and integrated into the Azure pipeline work with Terraform?
Have I used it, or
That's
how have I?
how have you used it, or have you used it? I
Um,
suppose it's a good question to
yeah,
start
so
with.
the last place I was working as a consultant, we used Azure DevOps as our orchestration tool, and we used Terraform. It wasn't anything amazing. We used the normal agents. We just ran a job that installed Terraform on the agent. We kept the state files in a shared storage that was locked down to only the accounts that run the Terraform pipeline. Yeah, and then we just ran the code and then cleaned it up afterwards with the pipelines. I'm not sure if that answers the question, but it wasn't complicated to set up at all in DevOps or GitHub Actions.
I think so. The other part was, how are there options to co-develop or access blueprinted common infrastructure patterns? So one of the, or part when you partner or become a partner with HashiCorp, one of the things that we have been working together with a lot of our partners is around the concept of design-in. And design-in is a mechanism that basically talks about all of these things that we've just talked about. Using repeatability, using standardized modules, looking at customer-based outcomes. So how do we work with you as a partner to deliver a set of outcomes that is going to deliver a solution for the customer, for example. So around that is we've, that's the standard things that we've done as part of the customer process or partnering process, and we're happy to, if you reach out or on the website, you can become a partner that way. The other question was, how good is the code quality outputted to data using Terraform? How good is the code quality
Oh, it's
outputted?
still in progress, so it's not too bad. I think with Azure specifically, when I was testing it earlier this year, some of the nested things like networks, it was a bit iffy on, but I know the team's been working on it. It's a hackathon open source project, so it's not, super shiny or a paid for product, but it's still pretty good, I think. Well, I was impressed anyway, after having to manually code environments into Terraform just so that my whole environment was covered. So for me, it was still a shortcut, but it's not 1,000% great yet, but I think it's pretty good.
Cool. So just a couple of questions which are basically common confusions. So digital blueprint, so Azure blueprints, and this is, I think this speaks to the naming convention that everybody kind of goes to. As soon as they get, and one of the things that we do is why we talk about patterns and why we tend to use the term patterns, because it avoids all of the concepts of it's a blueprint or an Azure have blueprints, and there's landing zones, and there's other cloud platforms that have landing zones, and there's all sorts of wonderful things. So basically, a digital pattern or blueprint from in our aspect of this is that it comes out of that module registry. You've written code that is as Simone showed, has a coding standard that has repeatability. You can use it in any environment, and all you need to do is generate the right variables to put into that for it to deploy. Now, those variables can also be driven and created using something like an auto.tf files, which means that you can automatically create a file. That file then is generated based off of some script or context. That output from that file then drives the Terraform code to actually stand up and build. So you have an automated file that can actually drive that repeatable element. And that's where that, but the blueprint name obviously does get confusing. In terms of both enterprise scale module and as mod CAF, they're actually both Microsoft projects. They're both built and developed and supported by the Microsoft engineering teams. They're 100% done by Microsoft. They are on our registry because obviously to make it easy to consume and pull down, then that's part of the Terraform integration. It knows where the modules are, it knows where to go, it knows all of those things. The difference between them comes down to that thinking around what are you trying to solve. If you are looking to start, I suppose the way I would explain this to my kids is, one is the Lego set that comes with the instructions and you build the Millennium Falcon. The other one is you can build like anything you want, and but there's no instructions. And so all the bits are there, and you have, you know, all of the capacity to do whatever you like in the world. But the construct is a lot looser in terms of I'm getting the Millennium Falcon here. I'm building to my imagination now, and that's the CAF stuff as opposed to enterprise scale. The one thing I would say is that the CAF team have actually got some examples that are integrated into there. If you look into the examples folder, it's I won't say buried, but it's, you have to actually go and look a lot closer into and understand what the modules are doing to then get to that next stage. And then once you're in there, it will have, here's what you could deploy as a minimum viable product, here's what you could stand up, and then you can add and detract those modules to it. In terms of how have we seen, or how I've seen customers use it, is that I've seen this balance where I've seen them actually go both ways. So some want the flexibility, some want the easier button.
My demo is taking the longest it's ever taken to deploy.
Yeah,
It's
it
literally
always
going to
is,
take,
but
I've run it like 10 times.
yeah, that's probably why. Uh, there's a few more, there isn't a couple more questions. How to visualize the provision stage, also for security compliance. That's Terraform or Azure can show it connection between the VCP. I don't understand the other part. So can you visualize the provision stage? So there is a plan. Sorry, I'm going to cough. There is a plan. That plan can be exported, and you can use something like Blast Radius to run that through, so you can actually visualize what could happen that way. You can do the same. You can do the same thing with a I've forgotten the command. There is actually a specific command that we will actually output a JPEG, a PNG that you can feed into Blast Radius, and it will visualize it. In terms of the connection and showing it, what you're doing is depending on the platform you're using. So if you're using Terraform Cloud, or then it's from Terraform Cloud, and you've put the right delegation and SPs into Terraform Cloud to talk to it and set up your OAuth and API keys, or if you're doing it from your laptop, in this case like Simone is, then you set up your personal access and your personal keys to delegate that security. It's all using that same API mechanism that you would be using if you were driving this from the command line, for example. What Terraform is doing is taking the heavy lifting of understanding what do I need to build, what APIs do I need to call, and putting that into what we call the HashiCorp control language, into an easily readable and deployable format rather than the full SDK. That's I think covers that. The other question is what were some of the challenges you faced during the development of ATZ TFY? I don't know. You weren't involved in that though, were you?
Yeah, I'm not a developer. I know that there was a bunch of small things that the team's still working on around like the length of the name and the nested resources. So if you reach out to the team, it's only a couple of guys in the Terraform team at Microsoft who are working on it as a pet project. I'm sure they'd be happy to talk to you about it, or if you want to join them. It's not an official Microsoft product, it's just an open source project they're working on that I thought was pretty cool, and solves that problem. But yeah, those are the two main ones.
Cool. I think we're well over time, so I think we're going to have to wrap. There's lots of questions. I'd like to say thank you, Simone, and hand it back to Mel.
Thank you.
Right. Thank you very much, Dave and Simone, for the great presentation and demo. So I know that there are a couple more questions that have yet to be answered. We will get back to you after this session, given that we are well over time. We really hope that you found today's session useful, and as I mentioned earlier, the webinar was recorded and we'll make this available on our website very soon. We'll also be sending out an email to everyone who registered with the link to the recording. So if you've liked what you heard today and you want to know more about Terraform and Azure, I encourage you to check out our Learn pages on our website, which you will find at learn.hashicorp.com. Thanks again for joining us, and a big thank you to our presenters, Dave and Simone. Enjoy your rest of the day and see you next time.
Thank you.